in the recorder. Okay. Okay. So before you can use C++, okay, you need to go here where is your version on Visual Studio Community. Click Modify, and you need to download this desktop development with C++. It's 5 GB. Okay, and then you can use it. Okay, let's open the code first. I forgot to open my mic. So while this is loading, let's look over the problem first. So I only solved the subjects that require a program to write code. The other ones are questions mostly. Okay, so we need to create a function with two parameters n and x, which receive a natural number in that interval, and then we need to show the first n um, numbers that are divisible with x, but in descending order, so from the biggest to the smallest. This one is very easy. um, Here when you code in C++ and run the code, it will run this function main, and here there is some code to select a problem. Here we just select a problem, and for each problem I made a function. So this is the first problem. Here I so we declare the variables n and x and give them a value outside that interval, so then we can try to read each one until they are in that interval. So here we check if the number is in that interval, and if it's not, we try to read again. We do this for n, and then we do this for x here, and then simply we go from n to 0 because it's descending order, and we see out, meaning display. We display this I multiplied by x to show the numbers divisible with x, the first n numbers divisible with x in descending order. I believe this is easy to understand, correct? You understand this?
Yep.
Okay, then we go to the next problem. This one, um, this one is not translated correctly, so we go to the Romanian one, but you don't need to read the. Okay, so I'll translate for you. So we have a natural number n between 2 and 10 to the, so between 2 and 100, and this is the dimension of the two-dimensional array. So we have a square two-dimensional array, meaning same dimension, length, same number of lines and same number of columns. And then uh, we have numbers, random numbers, and we need to show the edge of this two-dimensional array, but in counterclockwise order. So we go from here, from this corner, okay, from this corner 1 here, we go here to the bottom, here to 5, we display this, then the bottom part, then the right part from 9 to 6 here, and then the top part. So you start from 1, from this corner. And the way I solve this, we simply show each side. So we start from the left side, the bottom, right, and then top. Okay, so first we need the dimension of the two-dimensional array, which is n. Then here it is a little bit complicated to declare and create a two-dimensional array. You have to use pointers in C++. In C# is simple, you just say like this, int, two brackets, and then name of the array. But here you need to use pointers. So basically we create and read from the keyboard the two-dimensional array, and then we display it to see it. And then to solve the problem, we start with the left side. Okay, so the column is fixed, which is the first column. Here you see 0, the column is fixed, and then we go from 0 to n on the line. Okay, this is the left side. Then when we display the bottom side, we have to show it, but without this corner, because we displayed it already. So instead, so the line is fixed in this case, which is n minus 1, and then what varies is the column, but we start not from 0, from 1, so we exclude this 5, this corner. Okay, and then we do the same thing for the right side. Okay, so here the column is fixed, n minus 1, and what varies is the line, but this corner is n minus 1. Instead we start from n minus 2, because we displayed this already. And then for the top part, we need to exclude both this corner and this corner, because we displayed them already. And again, this the line is fixed in this case, n minus 1, but we start from n minus 2, and here until 1, not 0. That this is equivalent to bigger or equal than 1. Okay, it's equivalent to this. Is it clear? If you want, we can run the code and see that this works. Okay, let's run it every time to see that it works. Okay, let's say problem 2, and let's say 5. You have to enter this line by line. Okay, so here is the matrix. Sorry, in Romanian we call this matrix, but let's call this two-dimensional array. Okay, so let's see, we have 1 1 1 on the left side, then 2 3 4 5, okay, then 5 5 5. Okay, so this works. See, this one, if you look at this, it works, but unfortunately there is a space missing between the two-dimensional array and the result. Okay, so see that this works. Okay, now let's go to the next problem. Let's see if it is translated. It's not perfectly translated, but okay. So we have a text file that contains at most, here is a mistake, so 10 to the power of 6 numbers, natural numbers, in the range 0 to 10 to the power of 9, and separated by space. We need to display in descending order the two largest distinct, so the two largest numbers that are not in the file, but they need to have distinct digits. They cannot have the same digits. Okay, and these numbers must be displayed separated by a space. Okay, and this is important. We have to design a time efficient algorithm. Let me check that my mic is working. And so if you have, here is an example, if you have this text, okay, this text, then this will be displayed. Okay, and I used the example to check if it works. Let's see first if my code works. So with problem 3, say it works. We have 97 and 95 using the example provided. Okay, and so first of all, let me say it one more time. So we need to from these numbers we need to display the two largest two-digit numbers that are not in the file and also have distinct digits. Okay, and I created an array from 0 to 99, and in this array the position will represent the number. Okay, the position will represent the number, and the value inside it will represent how many times the number appears in that file. Okay, and we only need from 0 to 99 because those are the relevant numbers, because we are looking for a two-digit number, for two-digit numbers. So we create the array from 0 to 99 and put 0 in each position, because we at the moment we have no numbers, and this is the path to the file. Okay, and before we go further, I must say that you need these three lines here. Include your stream. This is input output stream. This is for reading or writing to files. This one is the string class, and this one, you need this one because otherwise when you display or read, you need to say std and then like this, these symbols, and it's faster if you just say using namespace std at the beginning. Okay, now that we have the path here, we open this file, but we only read from it, and here we check if it opened correctly, and then we need an integer to read the numbers into. So here we read from the file one by one into this variable number. And then if the number is lower than 100, so if it's two-digit or less, we add 1 to that position in the array. Okay, then we close the file because we have everything we need, and then we need to find those two numbers. So I created this. Can be done more efficiently, but this is the way I made it. We have the two numbers here. We say they are 0, and we start from the end of the array because we are looking for the biggest number. So, and also in ascending order, so we start from the end of the array, from 99 to 10, and the condition is if at that position the value is 0, so if the number doesn't exist. Okay, and then the other condition is that the two digits are different. So this one, if you divide by 10, that means you get the first digit, and this is the second digit, and they must be different. Okay, so this condition, if these conditions are true, and if we did not find the first number, we place it in that variable, or if we did find the first number, we place it in the second number, and then at the end we display them here, and we know that we did not find any number if these values are 0. Okay, is this clear until here?
Yep.
Okay, then we go. I have 3 more tests. Do you have patience for three more tests? Should take about
Yes.
an hour. Okay.
Sure.
And if you want, I can send you the solutions. I will make a zip file. So let's open the English version first, and the Romanian. is not the code. The code is not that important. What is important is the logic behind solving this problem. Okay. This one is interesting. I wasted much time without finding a solution for this, but at, at the end the solution was very simple. So first of all, let's read the problem, but I will read it in Romanian because this one is translated poorly. Okay. So we have two numbers n and m, from 1 to 10 to the power of 9, and here I made a mistake in the code if I remember correctly, because no, there is no mistake here. Okay, so we have two numbers n and m in this case. So let's say this one is n and this one is m. Okay, and do you know what the composition in prime factors, you know what that is?
Decomposition.
I don't know the translation
Not
exactly.
so sure.
Okay, I will show you in paint. Okay, what this is. Okay, so let's say we have two numbers, so 100, okay, and 50. Okay, so we need to divide this by so we take the lowest prime number that is not 1, so this would be 2. Okay, take 2. We, sorry, we look for the smallest. We need to divide by the smallest prime number, so in this case this one is divisible by 2. Okay, and we divide as much as possible. So then 58 we divide by 2 again, this is 25, and here we cannot divide by 2. The next one is 3, but it does not divide with 3. 4 is not prime, and so we divide by 5, the next bigger prime number, 5. Okay, and then we divide this again, and we can say that after we do this, we can say that 100 is equal to 2 to the power of 2 multiplied by 5 to the power of 2. Okay, and this one will be, if you do the same, this one will be 2 multiplied by 5 to the power of 2. Okay, and the problem asks us to find what they have in common, in this case this one. See, so we need a number to the same power, but we only show the number, not the power. Okay, so we need to find what they have in common. Is this clear?
Yep.
Okay, so I had a bad strategy for doing this, but at the end I found a very simple solution. Okay, so we read the two numbers. We have two ints and an m. Here we read the n, we read the m, and we have a variable which we call a prime. But before this, let me first explain. We need a function to check if a number is prime. Okay, so we have this function here that returns a bool which is either true or false. We need a number that we want to check if it's prime. We have a bool is prime, we assume it's true, and if the number is divisible by anything between 2 and half of that number minus 1, that means that the number is not prime, and at that point we don't we even stop this for loop, because we know that the number is not prime, and then that is what this break here does. It exits this for, and then we return that bool, and we need this function because we need to change this prime number. Okay, so we have the first prime number 2, while the numbers are different than 1, because we'll do what we did here in paint. Okay, we'll divide until the numbers are 1. Okay, do this until they're 1, and we, if it is possible, so if the number is still still can be divided, then if it is divisible with that prime number, if it divides, Then we divide that number and increase this variable count. So here we count how many times the number divided with that prime number, and we do this for n and m, okay, with the same prime number. We divide as many times as possible, and then we compare these counts here to check if they are equal. And if they are equal, it means we found that number that they have in common. But also these two variables must be different than 0, meaning the number was divided at least once. Because if they are 0, it means the number was not divisible with that prime number.
Sorry, what does M count?
M count here?
Yeah.
Okay, so we have a n count. Here we count how many times n was divided with that prime number. And here we do the same for m. Okay, so we compare these two counts. And then after that, so here if they divided an equal amount of time with that prime number, and if they divided at least once, then we display that number, that prime number. And then we need to find the next prime number, so we add 1 to that number and check if it's prime, and while it is not prime, we still add 1 until we find the next prime number, and then this repeats until the numbers cannot be divided. Okay, is everything
Yep.
clear? If you want, we can use the example here to check if this works. Let's play this. Select what problem is this? First problem. Okay. 16500 and 1078. 1078. One second, my 8 key is not working. Okay. And let's see, 2 and 11. Let's see if that is correct. Yes, it is. See, 2 and 11. Okay, so this works. Okay, next problem. I'll show you. I will explain it here in the Romanian version. Or never mind. This works. 2. Okay, so problem 2. So we need to read a natural number n that is between 2 and 20, and then we need to create a two-dimensional array with this structure. So on this is called in high school they call this second diagonal. So you see, this is the second diagonal with 5, and then if you go to the left of the 5 you decrease by 1, and the same if you go to the right of that diagonal you decrease by 1. So we need to create a two-dimensional array with that n, dimension being n, and then with this structure. And this is not that complicated. We have our variable n, we read it, we check if it's in that interval. This you should remember or have it somewhere in a file, because I don't know the logic behind this. Okay, because here you have pointer over pointer, it's complicated, but basically this means we create the two-dimensional array, which I called A, just A. And then here we solve not create, but create the structure of the array according to the problem. And we go line by line, so from 0 to n, minus 1, of course, n minus 1. And this one is the formula for the second diagonal. So this is fixed here. This is the formula for the column, and here obviously we place n, because if you see here in the problem we have a two-dimensional array where the length is 5, so on the second diagonal we place the length, which is 5. So here n is the value, and then we go to the left and the right of that value on the diagonal. Okay, let's if you go to the right, we start from we need to add 1. So if that value on the diagonal is on the n minus 1 minus I column, then we need to add 1 to go to the right, correct? So here we start from, instead from n minus 1 minus I, we start from n minus 5. So we added 1. And we go to the right, so we increase this until n minus 1. And we need to count when we go in a direction to know what number to place there. Okay, so then we place n minus count. And if you want to go if we want to go to the left, then we subtract 1 from that position. So instead of n minus 1 minus I, we start from n minus 2 minus I, so we subtracted 1, and we go to the left, so we decrease this until 0, and the same logic here. We count and we place n minus count. Okay, and let's check if this works. Let's try problem 2. Okay, see, this works exactly. This looks exactly as that two-dimensional array from the problem. Is this clear?
Yep.
Okay. So the next problem, it is, as you can see, it's not well translated. Okay, so we have a text file that contains 10 to the power of 6 numbers between minus so in this interval here, separated by space. So we have, for example, this here in a text file. Okay, and we need to find the longest sequence, sorry, not the longest sequence, but the length of the longest sequence that either starts or ends with a positive number. So if we have this, this is the sequence, the longest one, that here in this case starts with a positive number, and the length of this is 11 in this case. But one problem is I read the problem incorrectly, so instead of displaying the length, I display the whole sequence. Okay, so let's assume we display the whole sequence. Okay, so obviously the longest sequence is begins where we find the first positive number. Okay, so you need to realize that the longest sequence that starts with a positive number starts at the first positive number. But there is a case where we don't have any positive numbers until the end, and at the end we have a positive number, and that means that the whole text, the whole yes, the whole text is the longest sequence. Okay, so we need to take that in consideration. But uh, first, let's see what I did here because I forgot. So we have the path of the file. We open it to write from it. Sorry, to read from it. We check if it opened. We have so first we open it just to count the numbers, to know how many there are. So first we open it to count. Then we open it again to find the starting position of the longest sequence. Okay, so we go here. We go number by number. We count, and we count because we need to know. We need to check. So if the number is positive, we also check if we are not at the end of the sequence, because if we are at the end of the sequence, then that logic doesn't work anymore. Because if we did not, if the only positive number is at the end, that means that the whole text is the longest sequence, because it asks us to find the longest sequence that either starts or ends with a positive number. Okay, so if we are not in that worst case possible with only one positive number at the end, then we find the starting position here for the uh, longest sequence. Okay, and then we close the file because we don't need it, and we open it again, and here I display that sequence, but we I you don't need to do that. You just need the length of that. So basically um, you you need to calculate that length, just that length. Here I display that's the whole sequence. So I go number by number, and if it's not the worst possible case that we discussed, so if the starting position is different than 0, then we check if we reached that position, and if we did, we display the number. And if it is 0, I don't know what I wrote here, but anyway, that is the logic. It doesn't matter the code. The idea is that you need to the longest sequence is the when you find the first positive number, and in worst case scenario it is the whole sequence. Okay, let's open the next one. One second, let me take a sip of water. One second. Okay. Let's see if the English one is readable. Now it's not very readable, but okay. So we have two numbers. Okay, n, which is a number between 0 and 10 to the power of 9, and c, which is a digit. C is a digit from 0 to 9, and m is the result. And the idea is we have this number, and we need to remove that digit from that number. So if you have this, if we remove the 5s, we are left with 072. The 0 is meaningless, and so the result here is an error. This should be M. It's so the result is 72. Okay, so we need to remove the digit from the number and show the result, basically. And so we have the two numbers N and C, which is the digit that we need to remove. In M we save the result, so we read the N value, we read the C value, we check if it's in that interval, and then we have an array from 0 to 9, sorry, in this case from 0 to 8, so with length 9, and here we will save the digits of the number in the same order that they appear in the number. Okay, so but in the before that we place -1 in each position, and that will mean that at that position there is no digit. Okay, excuse me 1 second. Okay, we have an int number digits. We will count how many digits we have. So while the number is not 0, the number, we add from the right side of that array, because we take digits one by one from. So let me explain. So let's create a new file. Okay, we have this number, let's say, and we have the array. Okay, and these are the positions. So this is 0 1 until 9 or 8 in our case. So we take this 5 and we place it here, then we take the 4 and we place it here. Okay, so that's what we are doing. Okay, we're creating the number in the array, but we start from the right side, because that's the only way to do this. And after we add the digit to the array, we obviously divide by 10 the number to go to the next. So after we add this one, then we eliminate it. Okay, so the number is 1 2 3 4. Then we take this one, eliminate it. Okay, so that's the logic. And we have a bool here that will tell us when we find the first digit that is not 0, and that will make sense in a couple of seconds. So we go from left to right of the array where we have the digits of the number. If they are that digit that we need to remove, so C, if that is C, then we replace the value with -1, so we basically eliminated that digit. Then if we find a value that is not 0, then it means we found our non-zero value, so this becomes true. And if we did not find that non-zero value and we find a 0, that means that the 0 is meaningless, so we remove it as well. Okay, here we construct the number, so we start with 0, and we add a digit, and then we multiply by 10, add a digit, multiply by 10 until we create the number. Okay, so we go from 0 to 9, from the beginning to the end of the array, if the digit exists, so if it is different than -1, and then we add it to the number, and at the end we display it here. Okay, this one is clear, right? Do you understand this one?
Yep.
Okay, excuse me, I had some problems with anxiety the last days.
No worries.
Okay. So the next problem. This one is similar to the previous test. We need to create a two-dimensional array. So we have the dimension and we create so it's the same, but on the second diagonal we place 0, and then we add 1 if we go to the left or the right. So it's basically the same, but a bit different. The value differs, the logic is the same. We'll not go to this one because it's very similar. So let's go to the third problem. Okay, this one is very complicated. I had to comment every line because it's very difficult. Maybe we'll just go over the okay. So sorry, this is the Romanian language, the Romanian version. This one is unfortunately very poorly translated. Okay, so we have a text file with numbers, positive and negative, and let's see. So we need to find the longest sequence in this text file that contains only one negative number. So this one would be a sequence. Okay, this one would be a sequence. This one would be a sequence, and this one would be a sequence. So the longest sequence. So the length of the longest sequence that contains only one negative number. Okay. First, let's see if it works. I'll use the example. Let's see. So maximum length 6. Let's check. Yes, it is 6, so it works. Let's go. This is very hard to explain. I will only explain the logic. So the idea is, the first idea is to go until you find the first until you find the negative number. So you go until here and say this is a sequence, correct? And then you say from here to here you find another negative number and say this is a sequence. But this is not correct because let's say because the sequence doesn't start from the negative number and then you go to the right. Okay, you also have to consider the numbers before that negative number. Okay, so here let's see the logic. So that's the idea. When you find the negative number, the sequence doesn't start from it. It starts. You have to consider the numbers before it. Okay, so you count, but you also count. You keep in mind the numbers before it. That is the logic of it, and it asks us to make a algorithm. Let's see. An efficient algorithm in terms of memory used and execution time. So when you have this kind of text problem, ideally you should go only one time through these numbers. Okay.
Does it say if they have the same length, the longest pattern sequence?
Excuse me.
If the longest sequence have sorry, if the length of the longest sequence are like there's two of them present. I'm sorry.
If there are two that are equal
Yeah.
in length, it doesn't matter. You just pick either one.
Okay.
Okay, so let's see the logic here. We have the path, we open to read from it, and this sorry, I will talk a little bit slower because I don't feel very good. So we have this int number where we read into it one by one the numbers from the file, and then we have this count. This is the size of the of one sequence of a sequence. Then we have max count, which is the maximum size of the size of the biggest sequence that we found. And here we use this to check where sequences start and end. Okay, so this will change when we find a negative number. Then we have this counter that counts the numbers that are to the left of the next negative number. Okay, so we add this to our count when we start to count to take in consideration. So uh, we, we when we find this minus 23, for example, we don't only consider this, but also the numbers from the left. So we keep that in mind when we start the count. And here we have a bool for first negative when we find the first negative number. Okay, so we read one by one. If the number is negative, then we increase that negative count. Okay, and this is the logic for the first negative number. So then here we found the negative we reset that left count here for the first one. And also if we when we find a negative number, it means we need to start comparing our sequence to the maximum sequence, and that's what we do here. We compare the sequences, and if it's bigger, then that we replace the max count. And if the number is positive, obviously we add to the count, both to the left count and the count. So that's the logic. And excuse me, 5 minutes, we take a little break. Be right back. Okay, I'm back. So is this clear, at least the logic of this?
Yep.
Don't worry, I will. If you want, I can send you the code. But I'm sorry, I don't feel very good. But we'll go through the last test and then we'll stop. This is the last one. Okay. very badly translated, but so I will explain it fast. So we have two numbers, x and y, and this will be an interval, so in this case from 11 to 21, and every k numbers, so in this case for every 4 numbers we add this symbols, this star symbol. So we display the numbers from x to y, and each k numbers we display that symbol. Okay, and at the end, if it's not we add that star anyway. Okay, so we read the x, we read the I, but we make sure that x is smaller than y, and then we read the k, check if it's in the interval from the problem. So we start, we have a variable current and a current number, so we start from x, and we have a count, so we count when we reach that, so here we count until we reach that k number. Okay, so while we are below or equal to y, we display the number, increase the count, and if the count is equal to k, so if we reach that, so every k numbers, reset the count and show that symbol. And if we reach the end, we show that symbol anyway. So this one is very simple. Okay, let's try the second one. So this one is very simple. We have a number, in this case this 1359, and we need to create an array that has the a two-dimensional array with the length equal to the number of digits of that number, and then on each column we have the digits of that number in order. Okay, that's the problem. So we read the first, we read that x number, which is a natural number, so unsigned int. Okay, and then we create that array. Here we create the array. Okay, did someone else join? Okay, I see some people join. Unfortunately we are kind of at the end of the lesson, but okay, so I will repeat the problem again. So we have the number, a number, in this case 1359, and we have to create a two-dimensional array with the length equal to the number of digits of this number, and on each column we have the digits of the number. Okay, so first we need to read the number. We have the number, and then we create an array where we save the digits of this number. Okay, and we create the array here, sorry, this line, and then on each position we place -1, so that would mean no digits are there. Okay, then we place the digits one by one in the array from the right side. So I will explain this one more time. Okay, let's say we have this number, and we have the array, and we take this and place it here. Okay, then we remove it, take this and place here. Okay, and at the end we'll have this, and in the other positions we'll have -1, which means no number. So that's how we create the array. Then we create the two-dimensional array, and for some reason I started constructing this array from here, from the bottom right corner to the left top left corner, but this is just placing the numbers in the array. And because and after that we display the array. Okay, any questions here?
No.
Okay, this is the last problem.
No.
This is the last problem. Okay, I'll the translation is bad in English, so I'll just explain it. So you have a text file that contains digits, at most 10 to the power of 6, and we need to show in ascending order the even digits. Okay, so within this let's assume this is the text file. We take the zeros, which appear 2 times, so we show that 2 times. Then the 2's appear 4 times, so we show them 4 times. And then the 8 appears 1 time. Okay. So we will create an array from 0 to 9. The position will represent the number, and the value will represent how many times that number appears. Okay, so we place 0 in each position. Start from 0. This is the path to the file. We open it to read from it. We have this int number, which is we read into this variable one by one the numbers. And we added that position, we increase that position with 1 each time. We close the file because we don't need it. Excuse me 1 second. Okay, so we go from the left side to the right side, so we start from 0 to 10 to 9 because we want the numbers in ascending order. And if it's even, then we display it how many times is necessary. So from that value to 0. That's it. That was much simpler than the previous problems. Okay, so these are the only ones I have prepared. Okay, I'll see, maybe we'll discuss these kind of problems in the future. And tomorrow we will try to complete our game in Unity, and Sunday probably we'll start a new one. I'll think of an idea. So that's it for today. Thank you for coming. If there are any questions.
None for me.
Yes. Yes, please.
Oh, I said none for me.
Not for you. So I understand. I understood one for me. Okay. Okay. So see you tomorrow, guys. See you at the same time, and we'll discuss Unity.
Okay.
And Duncan, thank you. Thank you very much for coming.
All right. Thanks, Don. See ya.
See you.